Good evening, good morning, good afternoon, depending on the time that you're watching this video. It's something that I just thought of doing. Thought maybe we can help each other. Those who are doing environmental studies, perhaps we can help each other in calculations as you learning, this whole journey. Second year, third year, fourth years. So basically on this channel, you can, in the comment section, write a specific topic that you may need an explanation, or maybe where you need help in terms of calculations. And then on our spare we can find time and then maybe try to explain how it is done. So this is the first video that I'm making, and this is hydrology. I guess this should be second year, second semester on the water budget. Okay. So basically here you are looking at hydrologic cycle. These I'm sure you've read, you've been taught. So basically on the hydrologic equation or water budget equation, you're looking at this is more like a concept of conservation of, it's similar to conservation of mass or something. So what you get in must be equal to what is going out. And then that results in change in storage. Okay. So that means if what goes with what comes in is equal to what goes out, then there is no change in storage. In nature, it may not be possible. Let's take an example of a river. Okay, it can't be a whole watershed, but let's take specifically maybe a certain point in a river. Okay, you can't say the water that you receive is the water that goes out. So sometimes it might be more, sometimes it might be less, but normally it might be less. If we say we can close it up, maybe it's a lake, stagnant water, we pump in water, then we leave the water to drain. There's seepage, there is evapotranspiration. There is evaporation. So those things it may not be possible that the whole water that you have pumped in, maybe in 2 hours it will all go. Okay, so this is basically what this equation is telling you here. So Q initial or Q1 minus Q2 or Q0, okay, or input flow rate, output flow rate, and storage. So if you receive let's say 3 cubic meters of water, and then you go with 1 cubic meter of water is withdrawn by one of these processes, then what will remain is 2. Now if initially it was a 3, then you have taken out 1, that means there is a change in storage, and then the change in storage is 2. Now this is what this equation is telling you here. So when you go on the exercise that you're given, Now, because this is just an introduction, and I believe you might have done this already, or maybe you haven't done it. But I should know what you think if we should go ahead and solve it. But basically, we can find another example that we can solve, since this one is an exercise, so you must do it. Then we can find another example where we can solve, and so that you understand. Now, exercise 3.1, the water budget method used to determine evaporation from a lake or reservoir is based on the balance between inflows, outflows, and change in storage. So the following table gives the monthly total precipitation, the monthly average stream flow into, which is Q, and out, which is Q naught, a lake, and the net seepage, which is the difference between the two, QS minus QD. For a lake with a surface area of 1.295 square kilometer, so find the average losses in millimeters per day using the water budget method, assuming that the surface runoff is negligible, meaning this one, because we know runoff we are not including it, and the storage does not change. Key thing, storage does not change. Okay, so now what does that mean before you even start solving? Okay, here, so if the storage does not change, then automatically this whole thing here is equals to 0. Then what does that mean? That means that Q1 minus Q naught is equals to 0. Okay, then this means Q naught, Qi is equals to Q naught. So this one now tells you that your main job is to identify which ones are inflows and which ones are outflows. Then once you identify those, then you need to play around with the units. Then it means we have already showed you the equation now, which becomes Q is equals to Q out. Okay, so then once you find the Q1s, you find the Q naught, then you equate them, and then you can solve for something that you don't know. So now you should know that then you need to play around with the units. You have the area which you're going to use here, you use it at some point, and then you also need to take into consideration the final units that you need. Okay, I think that's it for tonight. Let me know what you think and what you want us to do. We can help each other. Where you don't understand, you comment, and then we can explain, and we can try to solve to help you learn better and pass your courses with flying colors. All right, thank you.